Okay, consider the input example. The input array that has 8 elements in it, which is 5, 2, 4, 7, 1, 3, 2, 6. And it is unsorted. And the starting index is 1, and the end index is 8. So in order to sort this array, we need to call the merge sort procedure like this. We need to specify the indices here, right? So what the procedure does, what the algorithm does is to first compute the midpoint, right? In our case, the midpoint is index 4, okay? So it is actually here, right? And we use this midpoint to divide the problem into 2 subproblems, which is the first call on the first subarray from 1 to 4, and the second call of merge sort from 5 to 8. Okay, I probably can use different colors here. Use the eraser, okay, and let's give it a different color to the second call, okay. And lastly, we'll need to call merge. All right. So now let's step into the recursive calls. Okay. Let's focus on the blue one, the first recursive call. Because it's a function, it's a call function, it's a call procedure. It will do the same thing as defined by the function, by the code of the procedure, right? So by the definition of the merge sort procedure, this recursive call, will result in what? A new call. So it will do some new computation by computing. It will further divide the current problem, because in this call, the starting index here, right? The starting index 1 and 4, they are not equal values. So it is not the smallest subproblem yet. So this subproblem can be further divided, okay? So we will divide the problem again by computing the new midpoint, which is 2, okay, which is here, okay. And then we further call the merge sort itself upon this even smaller subproblem from 1 to 2, and the second one from 3 to 4, okay. Okay, you may notice that here we are not done yet. Calling merge sorts on 1 and 2, this is still not the smallest problem yet. There are 2 elements in the array. So it will simply further divide the problem by computing another midpoints, which is 1, okay, and another 2 recursive calls on merge sorts on A11, and another recursive call on A22. Okay, now it's the point that we need to stop, because the merge sort here is called upon a input array with just 1 element, and same likewise for here. So these 2 calls will be instantly returned, right? Because they don't need to do anything, right? So after this one is returned and this one is returned, the merge procedure here will be executed, right? Remember, what the merge procedure does is to take 3 indices, 1, 1, 2, and the array that hold the elements 1, 1, 2. So it'll take basically merge these 2 subarrays. Okay. So merging these 2 subarrays, it will result a longer array that is in sorted order. Okay. So basically here we do nothing, and after merging the A11A on with indices 112, this call will be returned, right? So that means the merge call over here will be the let me open up another bigger pen here. So the merge sort here is returned. Then after this call is returned, the second one will be executed. Okay, the second yellow one will be executed. That means we need to further divide the problems. Okay, until we hit the smallest subproblem here, and here we also do nothing because they are the smallest elements, and then we merge these two sorted one, and this one is also returned. Okay, so after the yellowed one are all returned, the merge procedure will, excuse me, the procedure will also be returned. Okay, so until this one is returned, then this first subproblem is solved. Okay, and then the same thing needs to be repeatedly solved by a similar process to solve the second subproblem here. And after the blue one and the brown one are all solved, the final merge step need to be conducted. Okay, so that's how the recursive call happens. So eventually, if we look at the process from a bottom-up style, we look at what sub-areas are being merged in the whole process, then we can notice that the first one being merged is here, right? The first merge call is on A with index 1, index 2, index 1, and index 2. So we are merging these two sub-areas, okay? So the first one happens here between 5 and 2, because the merge will take the smaller one and put it at the head, and then take what's left in the areas. So the results of merging 5 and 2 will be the sorted order of 2 and 5. And similarly, merging 4 and 7 will result in a longer sequence, sorted array with 4 and 7 in it. And merging 1 and 3 result in 1 and 3. Merging 2 and 6 result in 2 and 6. Okay, so that's the first layer of merging. Okay, first layer of merging. And then let's consider the next layer. Next layer is like we need to merge the sub-array 2 and 5 and 4, 7. So if we merge these two, the result will be 2, 4, 5, 7. Okay. And merging 1, 3 and 2, 6 will result in 1, 2, 3, and 6. They are all in sorted order. Okay. So the last layer of merging is at the top level, in which we merge the two subproblems, sub-areas, which results in a sorted order of the whole array. Okay, so comparing the first element, takes the 1 out, and comparing the second one, take it out, and third one, take it out, and so on. Okay, so that's how the merging procedure is called and happens in the merge sorts algorithm. Okay, so that's it for the implementation and visualization of merge sorts. I think the best way to get through it is to use some examples and to work it out with your on the paper with some random numbers, and to figure out when a recursive call occurs and when the merge call returns.